Good morning, everyone. Really big group. You guys know this is a MySQL talk, right? Well, the other room's full, yeah? Okay, cool. So just before I start, I just want to say, kind of thank you to DPC for having me. This is my first time here. Thank you to, the sponsors, iBuildings for organising the other sponsors, because, without those guys, we wouldn't be here, you guys wouldn't be here, and this place would be a bit more quiet. So, thanks to them. MySQL. It's a funny thing, really, isn't it? It's one of those things that, you've probably been using for years. If you, first picked up a book or went online to learn to build, projects with PHP, and it says about, yes, you must do data persistence, then use MySQL. Here you go. And you go, okay, great. I can do an insert. I can do a select. If you're lucky, you can even create an index. Awesome. But it's one of those things that certainly I know I found that I didn't really keep up to date with it. I kind of learned MySQL back when I started PHP, PHP 4 and MySQL 3 or whatever it was back then. And I've always known those basics, and I've never really took it any further. Yeah, we do the same with other language, with other things we use. We learn about the new features of our frameworks. We learn about the new features of the languages that we're using, our IDEs, the other tools, the new development practices, pair programming, and those sorts of things. But often, MySQL can feel a little bit left out. It's kind of like put in a corner, and everyone kind of uses it and kind of just pretends it's not really there. You might use alternatives from time to time. You might use Postgres. You might use Mongo, whatever else. But it's one of those things we tend to come back to. So, who am I to be stood up here talking about this stuff? No one, really. My name's Liam Wiltshire. I'm a senior PHP developer and business manager. I have no idea what that means. For a small company called TEDx. I said we're a small company based in the UK, but we do in-game server monetization platforms for sandbox games, like that one. My kids think it's awesome. So you probably, hopefully, the fact there's lots of you here, you're not thinking this question. But the question, when I first started thinking about this talk and going, it's a talk I'm going to write and go and give at conferences, the question I got a lot was, but everyone knows MySQL, right? That's what we said. That's one of the first things you learn. You learn how to persist data. You stick it in a database, or back in the Perl days, you might have used a text file. But it stores data. Surely that's all there is to it. I would argue that's not the case. It's always been the go-to relational database management system for most PHP applications. I said there are alternatives, but the first thing you often learn, and the thing that often you'll come back to, is this. Things like WordPress use it. Things like Magento use it. A lot of frameworks, it's the default database engine. But it's one of those things that it does a lot more than just store that data. And it has a lot of things these days that can be used to make your life as a developer better and probably make your applications better as well. So in the next 45 minutes, what I'm going to try and do is go through 10 features that hopefully you at least don't know some of them. If you know all of them, by all means, come and do this talk next time. That's fine. And I'll sit over there. But hopefully some new things you'll learn. The first one I want to start with is like mind-blowing. It's the best thing that's ever happened. Coming in the new version of MySQL, you'll be able to query real life. Okay, that's a lie. But, we might get there one day. So, okay, let's look at some actual features. Some of these you may have heard of. Some of them you definitely won't. Some of them are actually brand new. So I've put version numbers with some of these things. The version numbers relate to the MySQL version that they were released in. So if you're using kind of Pacona or Maria, the versioning might be slightly different, or there might be features that aren't quite ready yet or whatever else. Some of these features are actually version 8, which has been released for developers, and I use it on my test environment, but it's not had a general release yet. I was bugging David Stoker for when it was going to be released, but he wouldn't tell me because he's mean. So the first thing we're going to look at is NoSQL, specifically JSON. Hopefully some of you guys may already know about this, but it's one of those things that's been picking up quite a bit of traction in the MySQL sphere. MySQL now has a native JSON type. Hooray! The important thing is that the data is stored in a binary format, so it's not like the old days where you'd have a text field and you'd whack JSON in it and then hope to God that you can make sense of it later. It means that because it's stored in a binary format, the engine doesn't have to parse everything every time. And it means that you can query things like the sub-objects and nested values and that sort of thing directly. So it makes life a lot easier for those things where you don't necessarily have a rigid data structure and you might have kind of various metadata. There are other ways you might do it. You might stick it in a separate table and then do queries on that or whatever else, but it's quite a nice way to be able to achieve it. There is some downsides. Like other binary columns, you can't index JSON columns directly. There are some ways around that, which we will come on to, but I know in some other database engines like Postgres, you can index JSON columns, but that's something that you have to do it another way here. I know it's something they are working on, but I don't know when that might be. So here's an example. I'm just creating a basic table, table called talks. And of course, we're all using UUIDs, right, yeah? No, I'm not. It just looks good on here. But we've got a UUID, and we're storing it in binary because it compacts it. It's great. And we are creating a data type, a data column with the JSON type. And then we're inserting value into it. So we insert the JSON just as a normal JSON string. And then MySQL will make sure it's valid JSON, which is nice. And it will then turn it into this binary format, pack it all up, and store it. Everyone wins. The first bit is turning a UUID into a binary value. Incidentally, in MySQL 8, there is actually a UUID to bin method that will do that for you. That's not one of my 10. That doesn't count. But that is something that will be coming as well. So we can insert data. Great. Probably want to get some data out as well. There are a couple of ways to do it. So MySQL does provide some actual functions like JSON_contains and JSON_extract and other stuff. But they're a bit lengthy and a bit of a pain, and no one really wants to use them. So they also provide some shortcut methods, kind of like arrows with 4 heads or something, to provide some shortcut ways of doing it. So here we've got a couple of examples. So first of all, we are using the full function to check that we're defining a new JSON object where the key title equals adventures in MySQL. And we're checking that that exists inside that data field. So it will check that there is, inside the JSON object, there is a key of title that contains that value. And that's using the long method. We can then use the short one, so the single arrow, which is just an extraction. And it will check that there is where data has a path of the root.summary. So in all these instances, the $sign is used to represent the root of the document. So when we had here, we had a summary directly inside kind of the top level of the object. That just refers to the top level, the top of the object, and it contains summary, and it checks it's not null. So as long as it has a summary, it will return it. If I inserted another one that didn't have a summary, it wouldn't. And then finally, just doing an extraction again. So we're just going to pull out the title from the talks table. You can also do more nested things. So let's say we did an insert where we actually had a talk data with then a sub-object of title and summary. You can do the same. So again, we just define the whole path. So it's $.talkData, so going to that first object, and then the title attribute of that object. And again, we can either do an extraction, we can do a check on it, contains, all the usual things. One thing to be aware of with the MySQL JSON methods is that a lot of the methods you think you'll want to use will actually return a quoted string, because it kind of returns a quasi-JSON object of its own. So like in this example, if I was to pull out the title, you notice actually the title comes out with quotes around it, which 98% of the time you probably don't want. But they thought about this. The MySQL guys are really clever. We'll use 2 arrowheads. Why not? I mean, yeah, why not 50? I don't know. But anyway, so there is a longhand way of doing it, which is there's a separate function called JSON unquote. But no one wants to do that because that's damn ugly. So we have this double arrow-headed thing that somehow that means it takes the quotes out. Not sure why, but it does. So it's all good. Let's talk about spatial data. We are here, whatever here is. This has been around for a little while. The first kind of geospatial stuff, the first OpenGIS support came in MySQL 5.5, but it wasn't very good, to be nice. OpenGIS itself is pretty unwieldy. If you've never really done anything with it, it's got a lot of kind of concepts and naming and the way things are structured that it kind of hurts your head, or certainly hurts mine. It still does. But that's okay. MySQL kind of have some nice wrappers for it now, and on a version-by-version basis, it's getting better. So we're getting more and more features. The things that they already have been improved. It is a bit of a pain, because bear in mind it's only been around for 2 minor versions. They've already deprecated a load of functions and created some new ones. Yeah, why not? So there are things, but it's getting to a much more mature state now. I would say with this, do consider if you really need it. I mean, if you're doing things like store locators and you've got thousands of stores and you want to find them in a nice circle radius and you don't want to write a load of grand circle theory stuff, then it's perfect for that. If you've got 4 stores and they're all in the same city, it's probably not worthwhile. So do just consider that. The performance is increased with this stuff because, as well as having some specialized functions and data types, rather than just storing stuff in floats or decimal all the time, it also has some indexes. So you can, you can do a lot better job of actually indexing this geodata. There are 4 main types. The geometry type is like this general class, and this is the way to think about these things. Is with the OpenGIS stuff, they are effectively classes. OpenGIS defines points, line strings, and polygons as objects. The geometry object is this general one. So a geometry object can hold any of the other types. But then you can also define a point, a line string, or a polygon, and that can only hold that type. So geometry can hold any of the other 3. The other ones are specific. For most of our cases, like if you're using a store locator or that sort of thing, you're going to be storing a point because it is a fixed lat long on a sphere-ish type object, I guess. But there are the other ones as well. It also does collections. Now, collections are kind of interesting in that they can hold multiple of that object. So a geometry collection could hold a point and a line string and a polygon and another point. How you'd make any sense of that, I have no idea, but you can. Or you can have a multi-point that can have lots of individual points, or a multi-line string that can have lots of lines, or a multi-polygon that can have lots of polygons. I've never used them, like, ever, but they are there. So, some people in this room that are probably far smarter than me will probably come up with some really cool uses for them. Back when MySQL first released the Geo Spatial Features, it only worked on flat planes. Last time I checked, we're on a sphere. So for most of our use cases, it was pretty useless. If you were working with like flat maps or things like that, it was great, and you could do all that stuff. But if you wanted it for like real-world things, like that worked on a sphere, it wasn't great. It didn't work. However, that got fixed in 5.7. We now have spherical functions as well. And they're quite cool because by default, they assume the radius of the Earth, but you can actually change the radius. So when Elon Musk launches Tesla stores on Mars, he's fine. And they all look like st_distance or whatever function we're using, and then _sphere. That's how you know it's the spherical function. So let's have a little look at this. Got some conferences. So again, I'm using UUID. A name of a conference and where it is. And you see we're specifying that it's of the point type. And we've got to insert a couple. These are in the US. I don't really know why. Just the 2 I thought of at the time, I think. Anyway, so this is still a normal string, and this is that function we did before for the UUID. But notice how this itself is an object. So we're defining a point with a latitude and longitude, and we're storing that object. And then we're doing the same for Sunshine PHP. And again, we're defining latitude and longitude as a point object. And then we can pull it out, so we can say, right, so now I want to work out the distance from this latitude and longitude, which is actually the stadium of my favorite NFL team, to the locations, and it'll pull that out. And notice, again, as I said, we're using the _sphere function to make sure it's working as though it's on a globe. And you get something that looks a bit like that. Not wholly readable, but we've got distances. The distances are in meters, which is great for most of us. When I first explained this in the US, they all looked at me a bit blank. But yeah, so the results are in meters, same as the radius of the globe. If you change the radius for the sphere you're working with, that's in meters as well. As you can see, as we mentioned, the actual location itself is stored in a binary format. So it isn't of any use on its own, but there are ways to then turn it back into something that's readable. So that's all good. So making it readable, there's a couple of ways you can do this. There's two methods. There's an st_as_text, not Aztec, as I said the first time I did this, which converts to WKT format, which actually is quite handy. There's a lot of PHP libraries that do geo stuff that use WKT format, so that's great for those things. Or you can export it as JSON. Odds are if you're going to be outputting it back to the screen for whatever reason, you're probably going to use the JSON format, because then you can parse it and it's all good. But yeah, so spatial stuff. I think that's pretty cool. Who here has ever done MySQL replication? A few hands. Who hates it? Yeah. OK, so MySQL replication has always been one of those things that we've had to do, and it's never really worked properly. It works in theory, and you follow the instructions, and you speak to people that know, and you do it, and it works for a couple of days, and then you do show master status, and it blew up last night. So you go, all right, OK, redump the database, find the point in the file, find which file it is, set it all up again, and it runs for a couple of days, and then it blows up again. And we carry on about this until we throw the server out the window. GTID replication fixes a lot of those problems. I can't show a full working implementation here because we don't have time. I've just spent 15 minutes on those first few slides, so it's fine. But this is more or less how it works. We know it's a pain. What GTIDs are global transaction IDs. So within your cluster, whether that's one master and lots of slaves, or lots of masters and lots of slaves, each transaction has a guaranteed unique identifier. Now, the reason that's useful is because it's a guaranteed globally unique identifier. Those can be passed between the different servers in your cluster to make sure they're all at the same point in the replication process without relying on the position in a file, because we all like that. This is how it works. So you have to turn it on all your servers. You can't have some with GTID and some with old school replication. It doesn't work. I wish it did, but it doesn't. But in your config, you enforce consistency, you turn GTID on, and then when you change your master, rather than all that old stuff with file underscore pos and file underscore name, just master auto position equals 1. That's it. It's wonderful. And then you can check your status and look. It doesn't have it still knows the file and position, but it's all worked out by itself. And now it can say, oh, the last transaction I executed was that one. So if it does stop, it still knows, well, that's the last transaction. It can go and find that transaction and carry on. And I can sleep at night, and it's wonderful. Explain's not new. Apparently, it's not. But they have added some pretty cool new wrinkles to it. So one of the first things is that previously you could only explain read queries. So you could do an explain on a select, or on a select, or on a select, which is useful. But what if you had some updates that were using some joins, or inserts that are actually querying other tables before it did the insert? You kind of didn't really have a way to do explains on those. You could turn it into a select statement, but even then, sometimes MySQL's optimizer, in its infinite wisdom, will handle it as a select differently to how it'll handle it as an insert select, because MySQL knows best. So yes, they've now added explain on write queries. There are some limitations. So if you have an explain insert, which isn't an explain insert select, it will just say, I'm doing an insert. But that kind of makes sense. There are some things that it would be nice if it did. Like I have said to the MySQL kind of developers that it'd be lovely if it could tell us about the foreign key checks it's doing when you do that insert, or when you do a delete, whatever else. But because of the way foreign keys are implemented, the checks are actually done by the storage engine and not the optimizer. So I don't think it will ever happen. But it's one of those things. It'd be nice, and if we all if we all keep shouting at MySQL, perhaps one day it might happen. Do it for me, please. So this is what one looks like. So we're doing just a basic explain, insert, select. As I said, the insert itself, not that useful. I'm doing an insert on news archive. Meh. But once said, it also then does the select, and it can say which indexes it's using, and all the normal things. It also works on updates. It also works on deletes. So that's something that I found really useful. The second part of the explain is the fact that there's now a JSON format, because everyone needs more JSON in their life. But seriously, what the JSON format does is, because normally explains, if you think about it, it's just rows with column headers. There's not much flexibility there. You can't go into an awful lot of depth. Because JSON has given them a much more flexible format, they can cram a whole lot more data in there. So it includes all the explain extended data. It includes all the explain partitions data and some other bits and pieces as well. It's as simple as just doing explain format equals JSON, and then you query. And notice here how we're using our favorite little JSON operator, JSON extraction again. And it starts here, and it says it's got the basic stuff. It's got, OK, I'm going to do an insert into the talks table. I'm going to do an insert from. So I'm going to be creating the talks table. I'm going to get everything from it. It gives you the read cost stuff, the conditions, what columns are being used, everything. It's brilliant. So here's another one. Again, we're now doing just a basic select. It gives you the query cost again, the tables, what the key, all the usual stuff, and the cost stuff as well. And it gives you a lot more insight than just a basic explain in a table does. So something that, again, I've found to be really useful. User roles. MySQL, for all its awesomeness, has always been a bit behind when it's come to users. You create a user, and you go, OK, so this is a developer. So we've got 6 developers, so I'm going to create another developer. That's fine. And I know he's going to need insert, an update, and these permissions. Great. And then one day, you realize they need to create new tables. Hang on, we've got 7 developers. Shit, I've got to go and do all of them now. And every one, you go through all the users and add the create permission. And then they don't need the create permission anymore, so you have to go and delete it again. That's a bit of a pain. So in the new version of MySQL, this is in version 8, so it does work in the developer release. They've now defined user roles. So a role is effectively a group of privileges that you give a label. So you might create a developer role, and a maintenance role, and an analytics role, for example. And you define on the user role level what the permissions are. And then instead of having to give users the individual permissions, you just give them that role. Which means if you need to update, let's say you've got an analytics, and you suddenly need to be able to create temporary tables, then you can give them those privileges on the role, and anyone who's underneath that analytics role will get those. If you've got developers and they suddenly need to be able to create tables, you have the create role, and you add the create permission to the role, and it filters down to all the users of that role. And equally, you can then take them away again without having to do every user individually. It's not a huge feature, but it just makes maintaining that sort of thing, certainly if you want to keep your permissions locked down as much as possible, it makes that sort of thing significantly easier. It's quite simple to do. You can define some roles. You can then define the privileges on each role, and then you grant a role to a user. That's it. It's fairly straightforward, but fairly handy. Generated columns. This is one of those things that other languages have had for a while. So other database engines have had for a while, sorry. And something that I think MySQL has kind of had to catch up on, but actually now, where we are with them, they're pretty strong. So generated columns are effectively columns that are made up by the engine based on an expression that you give it. It's almost like having a default value on a column, but that is an expression. It's kind of the same thing, except you can't overwrite it at creation time. There are 2 types. There are virtual generated columns, and there are stored generated columns. There are lots of uses for them. One of the things you might have is if you store in your application the first name and the last name as 2 separate columns, but you also need to be able to have them as one column, you might use a generated column to do that. The thing that you're most likely to use them for is indexing JSON data. Because as we mentioned, you can't index a JSON column, but you could have a virtual column that was based on the name that came out of the JSON and then index that. Told you there was a workaround. So this is what one looks like. And this, as I said, with that previous example, is being able to index JSON data. So at the moment, if we're going to do this select, and it's going to have to go through each JSON object on each row and read it and check the title, and it's going to be a bit slow. So we're going to alter the table, and we are going to add a column called talk title, which is generated, and the generation is going to be extracting the title from the JSON object in the data column. And this is a stored column. I'll explain the difference in a minute. And then because that is effectively just a normal column, although it's a generated column, it just gets treated as a standard column. So anything you can do to a normal column, you can do to a generated column. So we can stick an index on it, and then we can do that same query again using this new talk title column, and everyone is a happy camper. As I said, there are two types. The first one is a virtual generated column. The difference between the two is when the data is created. So a virtual generated column is materialized, and materialized is just the fancy word in MySQL for working out the value of this column, at read time. So when you do the select, a virtual generated column's values are computed at that point in time. That's good because there are no additional storage requirements, and it's good because if you need to change a virtual column, make it longer or shorter, it's really quick because it doesn't contain data while it's at rest. The problem with it, of course, is if you have a large record set and a really expensive expression on that generated column, that's going to become very slow. If you're doing that JSON extract at read time and you've got 100 rows, it's still got to then go through all those 100 rows and pull that data out, or 1,000 rows, it's got to go and pull all that out, and that's going to be very slow. There are also some limitations around indexing on virtual columns. So if you're using InnoDB, it can generate an index on a virtual column. The index itself, and this gets a little bit complicated, the index itself is materialized on write. So when you do an insert or an update, it will work out the value for that column. It won't store it in the column, but it will store it in the index. So far, so good. If you're then doing a select, and you're using a covering index, in other words, if you're doing a select and all the keys you're going to pull out of the database are in that index, then MySQL will use the index, and it won't rematerialize the virtual column. But even if the virtual column is in an index, but you're doing a select that also includes columns that aren't inside that index, it will then rematerialize the whole column. Yeah? I think that made sense. Maybe. It'd be fine. Stored generated columns. Who can guess what a stored generated column does? So quite obviously, if a virtual generated column isn't stored, a stored generated column is stored. That sounded better in my head. So in this instance, the column is materialized as you do the insert and as you do an update or whatever else. And it's stored in the table. At that point, it acts just like a normal column. Obviously, that does mean that you need to be a little bit careful, because if you have 1,000 generated stored columns, MySQL will shout, well, you wouldn't be allowed anyway, but MySQL will shout at you, and it can be a little bit, it will make your inserts and your writes slower. But it does mean that when you're doing a query, that data is already there, and it's not having to materialize it at read time. And of course, you can then do all the indexing and things on that as well. I use stored columns significantly more than I use virtual columns, but both definitely have their place. This is my favorite state. I like this state, offline. I wish I could be offline all the time, but I can't. Offline mode, so this is, again, it's a really small thing, but actually for us, it's had some big impacts. So what offline mode effectively does is it locks down the database and prevents access to anyone who doesn't have the super privilege. I like having super privileges. It can be done without restarting the server. So it's a useful way to be able to be absolutely sure your data is going to be consistent while you're doing maintenance. Hopefully your application has maintenance mode states anyway, but we had a situation. It's quite a funny story. So we have our new system. It's great. It's in Laravel. It's all shiny and unit tests, and it's great. And it has offline mode, and everyone's happy. And we have an API. And we had to convert everything to UTF-8 MB4, which, if anyone knows, is interesting. So we did that, and we put everything in maintenance mode, and we knew we were going to be offline for 2 hours. And then as we started this maintenance, we realized that data was still changing. We're like, how's that possible? We checked the API. No, that's in offline mode. We checked the application. That was in offline mode. What's going on? And then I realized we still have about 10 customers that use the old legacy API, which isn't part of Laravel. So when you turn stuff off, it does nothing. So they were just hitting this API, oblivious to everything, and completely screwing all our data up. And it was great. So then we used offline mode, and hey, everything worked again. So offline mode, it just means that it gives you that extra fail-safe. So you can lock down all access, and it's just as simple as setting a variable. Set global, offline mode equals on, job done. Indexes. Everyone loves an index. Incidentally, this is one of my favorite comics. If you've never seen Commit Strip, do go and check it out. It's hilarious. But well, it's hilarious in how sad it is, because you'll look at it and go, yes, that is literally my daily life as a developer. But it's good, it's good. So we now have invisible indexes. Ooh, scary. They're not scary. The problem with indexes is you have to maintain them. And often, over the course of the lifetime of an application, people add indexes here, people add indexes there. Then someone goes, hey, I need a covering index on those 2 columns. And then someone adds another index. And all of a sudden, you've got like 50 indexes on a 10-column table. What? So what an invisible index effectively does is it hides that index, makes it invisible, from the MySQL performance engine. So when it's doing its optimizations, when it's working out how it's going to execute this query, it will hide those indexes. So the optimization engine won't even consider them. So it means that you can test, if I get rid of this index, is it actually going to affect my performance at all, or is there another index that's going to pick up the slack? So you can make it invisible. It will still get maintained. So if you take it out and all of a sudden your application grinds to a halt, and you go, no, that was a really bad plan, you can just uninvisibilize it. That's not a word. Uninvisibilize it, we're going with it. And it'll come back, and it's fully maintained, and it's all up to date, and you go, no, that must have been a network issue. I love how everyone laughs at that every time. Yeah, it was a network issue. So you can hide it and check the performance. And then if you find that actually you don't need that index, then you can get rid of it. You do need to make sure that if you don't need them, you do still get rid of them, because if you just make them invisible, they are still maintained. So they are still being written every time you do an insert or an update or a delete or whatever. But it's a good way of just really quickly testing, well, do I really need this index, or do I really need that index? And yeah, that's pretty nice. It's as simple as that. You make it invisible, you make it visible again. Good stuff. Descending indexes. Who can guess what a descending index does? Yeah. Obviously, we use indexes a lot for speeding up queries. We also use them to actually speed up extracting data. So you can create covering indexes, like I've mentioned before, that if you're doing a query, that all the columns exist in that index. It won't even read your table. It will just pull the data out of the index, and it's all happy and roses and tulips, and everything's lovely. However, at the moment, all indexes are stored ascending, and you cannot change that. So if you're indexing time, it will always index oldest first, oldest to newest. If you're indexing by a number, it'll always be lowest to biggest. Which doesn't sound like a problem, but actually it kind of is. This is a wholly non-scientific experiment. It was done on my work machine, which does the job, and it explains the point. So for a long time, MySQL has been able to scan indexes backwards, so from the bottom up, but it is slower. So let's just assume in this example, we've got a news table, and on our home page, we want to show a news summary. Okay? So we're only going to show the headline and the date. We're not going to show the actual content. So we've got, I can make this quick with a covering index. So I create my index on date and headline and go, haha, brilliant. Except you're never going to show news from the oldest first. No one cares what happened in 2000. With all the news that's happening now, I can't remember what happened yesterday. So you want to show the newest stuff first. So you're going to show from the newest date to the oldest date. And if you do that at the moment, so this was on MySQL 5.7, in this example, I mean, I just generated 75,000 rows of garbage. It took 1/10 of a second. So yeah, it's using the index, and it's using a covering index, and it's pretty quick. But in MySQL 8, when you have a descending index, it takes half the time. And that's not a big, 75,000 rows these days isn't a lot, but it's halved it. If you're showing lots of news, and you're getting lots of views, and you're not caching, that could make a massive difference. So that's one of those things that I personally am very excited about. It's quite simple. You can just define it as descending, and you can even alter the version. So if you know you're going to show them by date, but if you've got multiple headlines on the same date, you then want to show them date ascending. I don't know why you do that, just use time. Anyway, but if you were doing that, you can specify one half of the index to be descending and the other half to be ascending. It's brilliant. So yes, it's one of those things that, once you start thinking about it and go, well, actually, no, we have got a lot of covering indexes, and we are showing it the wrong way around. It's really useful for things like that. So that's 10. But I lied. Why? Why have I got a picture of a Snares? Who had a Snares when they were younger? Cool. Quite a few people. Snares is a pretty weird image to have on a slide. And if I'm honest, I put the image up first and then decided to find a way to make it link. But I have got a way to make it link. It's brilliant. Because this last one, which is 11, but that's fine. We're OK with this. It's MySQL. It can't count. Isn't new. This has been around since the dawn of time. So like the Snares, it's an oldie but a goodie. No? No one? All right, fine. It's a Snares. Just enjoy the Snares. It's fine. So what is this amazing thing that I'm speaking of? I am a dummy. I'm a dummy in two ways. This flag has been around forever. I learned about it about 9 months ago. What this flag does is if you're using this MySQL CLI and you use the I am a dummy flag, it will not let you do an update or a delete unless you specify a where clause that uses a key. So who here in their life, and I'll put my hand up now because I know what's coming, has ever done an update or a delete on an entire table by accident? Everyone! Yay! I did one a few weeks ago because I forgot to use the flag, but that's by the by. So what this does is, you type your, and it happens, you type an update clause, and then you go to hit where something equals, and accidentally you hit the return key, and it runs. And in my instance, I set all the prices of all the purchases for the last 2 years to $5. I got into a little bit of trouble for that one. Big bit of trouble. But with that clause, it'll just go, no, you haven't specified a where clause that uses a key. And then you use a key, and then it lets you. Think about how many problems that would have saved if it was the default setting. I have often asked, why is it not the default setting? And in fact, on mine it is now because I changed my config file to use it by default, because you can set it in the my.ini. If you, in the MySQL-clients section of the my.cnf, sorry, not my.ini, you can specify I am a dummy equals 1, and it'll do it for you all the time, which is great. So yeah, that's like my favorite thing ever, which is why I'm allowing 11. There you go. But it is old. It's been there since forever. So that's about everything. I just want to leave you with a couple of thoughts, really. So we have a really tough job. We're writing code, we're trying to solve problems every day. At the same time, we're trying to keep up to date with all the arguments on the internals list, with all the arguments on Twitter, with the new features in whatever framework you use, with what's new in PHP Storm or whatever else. There's so much stuff that we have to try and keep a hold of. And it is difficult. I get that. But it's very easy to fall behind on the latest updates if we're not careful. So try and keep track of what's going on. Even if you just kind of dip into the what's new in MySQL once a year and just read through. You'll often find things that make your life easier and also allow you to make better applications. This is just a selection of a few of the new features. There are huge numbers of other things that I couldn't fit into 10 or 11. But do go out there. And it doesn't just apply to MySQL. It applies to everything you're using every day. So please, go out there and explore. Thank you. We've got about, I think, 5 minutes or so, if anyone's got any questions. Yeah?
Are there any expectations of XML?
So the question was, is there any expectation of XML? I don't know. To be honest, I don't know the answer to that. I know that other languages have XML support. I mean, Postgres has had XML support forever. Well, a few years anyway. I don't know. To be honest, I've never had a need to look into it. Perhaps that's just because I'm lucky. I will try and find out, and I will answer on Twitter. Anything else? Hopefully something I might know? Yeah? So the question was, when you're talking about generated columns, are there any limitations on what the expressions can contain? No, I don't think so. I mean, I guess there are practical limitations in that if you suddenly decide to do some grand circle theory in a virtually materialized column, it's never going to load. But as far as I'm aware, I've certainly never come across any. So no, as far as I'm aware, basically anything that is a valid expression, even subselects and things like that you can do, which I guess is probably what you were thinking about. Yeah, even things like that, as long as it's a valid expression and it can be materialized, as far as I'm aware, it's fine. Yeah? Yeah? So I'm gonna come up here. Yeah? Mm-hmm. Yeah. So the question was, if you had two indexes on a column, one that was ascending and one was descending, would it use the correct one for the specific use case? The MySQL optimizer is pretty intelligent. So as long as the descending one is a covering index, I would assume it would do. Sometimes if it's a new index, obviously you have to kind of train it and you have to get it to do the analysis and things like that. But at that point, yes, it should use the correct index. Is that it? Oh, yeah?
If you have a generated column,
Mm-hmm.
if you update the original one, will the
Yes.
generated stores?
Yeah. So the question was that if you've inserted a column and you had a stored generated column, when you do an update on that, will it rematerialize? And yes, anytime you touch a row with a write query, it will rematerialize any columns for that row. Same as if you have a virtual column, it will rematerialize it for the index. So in both instances, yes. Anything else? A couple of minutes? Or you're all desperate for coffee? OK. Well, thanks very much for coming. I hope you found it useful. Please, both for myself and all the other speakers, do rate us and joined in. Even if it's bad feedback, I'm not going to get better unless I know. Have a great conference, and thank you.